Everybody, this is Ryan Leonard with Eagle Dream Technologies. This is part one of two of an introduction to Amazon Sagemaker. So before we jump into Amazon Sagemaker, I want to quickly review the Amazon machine learning stack. If you saw my previous tech talk, you would remember that we discussed the AI services on the top level. These are services such as TECHTalk, which helps developers extract text from images and other documents such as PDF using OCR. Then there's services such as Forecast, which allow a developer to receive forecasts based on time series data. And the great thing about these services that I discussed before is that they're just an API away. Any developer can use these services without a great deal of machine learning background. Oftentimes these are great options when there's a very specific goal that needs to be achieved. And one of these services fits directly into that goal. So jumping down to the bottom layer, this is the machine learning frameworks and infrastructure. This is sort of the way that we've done machine learning for quite some time now. This includes frameworks like TensorFlow, MXNet, and PyTorch, and these are often run on sort of more traditional cloud compute such as EC2 or Elastic Inference. So going to the middle layer, which is Amazon SageMaker, in the core topic of our discussion today, really what the goal of SageMaker is to centralize the entire machine learning lifecycle into a single service, just to make the whole process a lot easier for machine learning developers. So this goes from pre-processing data to training models and ultimately deploying these models in a scalable environment. So let's get started on this discussion. So in the past, machine learning has been quite complicated for everyday developers. You have to collect and label data, clean, format, and transform the data, develop a model, train a model, evaluate that model, adjust incrementally until your accuracy metrics are satisfactory, and then you're going to want to go ahead and deploy that model to make predictions in a way that scales with traffic. So if you think about this, there are quite a few different skill sets required to do this. You have the skill set to extract and transform data, the skill set to choose appropriate algorithms and tune those models, and then the skill set to deploy, scale, and manage. As you might imagine, these are not skill sets that everybody has together. So oftentimes this will require two or more different engineers to sort of pull this type of thing off. And what SageMaker aims to do is just sort of make this process a lot easier with different components within the service. So there's 4 core components that we're going to be discussing in this video and in the next video: ground truth, notebooks, training, and inference. In this video, we will focus on ground truth and notebooks. In the next video, we'll focus on training and inference. So to get started with ground truth, everybody who has worked on a supervised learning problem understands the challenge surrounding getting labeled data or labeling unlabeled data sets. This is quite time consuming, and it's quite rare to get data sets that are pre-labeled for us. So what ground truth aims to do is to help us with that labeling process and increase the amount of time or decrease the amount of time it takes to end up with a labeled data set. So this is the main flow of ground truth. So the raw data goes to S3. Humans are going to start to label those records manually, and we'll talk about sort of the options for the human labeling component in the next slide. As humans are labeling these records, an active learning model is being trained from the human labeled data. Eventually, ground truth is going to start to try to label data itself with a level of confidence. If that level of confidence does not reach a certain threshold, which meaning that it's not confident enough that it's labeled the record correctly, it's going to kick that record back to a human labeler who's going to go ahead and label that record manually. And what this does is allow an active learning model to get better and better over time. And eventually it'll do, over time, it's going to do more of the labeling with a higher level of confidence, leading to an accurate training data set that's ready for use in Amazon SageMaker in a fraction of the time. So that's sort of the gist of ground truth. The whole goal is to reduce the amount of time that it takes to come up with a label training set training data set for supervised learning. Now, this is an example of the ground truth UI. This would be sort of thought about from the perspective of something like image classification, where the classes are cat, dog, and bird. So you have an image here. Somebody drew a bounding box around the dog, so ground truth understands, sort of what a dog is supposed to look like. This is just sort of an example of the UI. I don't want anybody to think that ground truth is just for images, because it can be used with other unstructured data like text, as well as structured, more tabular type data. So in terms of the human component of ground truth, there's really three core options. You have Mechanical Turk, which essentially is a marketplace for workers that you can essentially hire to do the human labeling component of ground truth, and you pay for this by the number of records that need to be labeled. Then there's private workforce labeling, which is exactly what it sounds like. That would be resources within the organization doing that labeling with ground truth. Then there are third-party vendors, and some of those are listed to the right here. This all depends on the resources available within the organization, and each organization might find that one of these options makes more sense than the other. All right, so notebooks. Before we even think about training models in machine learning, we typically have to do some data pre-processing. And oftentimes that's going to require a certain type of environment with tools and frameworks that we have to set up on our local machine traditionally. Now, the cool thing about notebooks is that they pretty much bypass the need to set up these environments on our local machines because we're simply spinning up servers that already have the environments that we're going to need. So they run on Jupyter Notebook, they support Jupyter Lab, and they support multiple built-in kernels. These built-in kernels could be something like Python, R, PySpark, and even frameworks like MXNet or PyTorch. So this is very convenient if you just want to get started quickly, and oftentimes that's what we want to do. You can also install external libraries and kernels. There's direct integration with Git, and there's sample notebooks with some really excellent examples of use cases with some of the Sagemaker built-in algorithms. So if you're planning to build a model using one of the Sagemaker algorithms, you can find examples of almost all of them within the sample notebooks. And we'll talk a little bit more about that in the next video. But generally speaking, pre-processing of data is things like removing duplicate records. Maybe you have to join some tables together. Get rid of some characters, reformat the data depending on the requirements of the algorithms that you plan to use. So really the goal of this is just to make the process a lot faster in getting started with that pre-processing journey. There's also a part of notebooks where you can actually train models directly from a notebook, and we'll talk a little bit about that in the next video. So that's pretty much all I have for this video. We reviewed ground truth and how that helps us classify data and end up with labeled data sets, helps us label data and end up with labeled data sets a lot faster than if we were to have to do it all manually. And then we discussed how notebooks could be used to pre-process data in an environment that is pre-configured for us. So I look forward to seeing you in the next video. We will discuss training and inference, and I appreciate you tuning in to watch this one. Thank you.